Hi, it's Shashi here. Today, we aren't just talking about a minor update. We're diving deep into the tech that redefined AI hardware, Google TurboQuant. Since 2023, the world has been in an AI arms race, but as models grew, we hit a physical limit that no amount of silicon could solve. It's called the memory wall. Processors got faster, but memory bandwidth and capacity didn't. This created a massive bottleneck for large language models. To fight this, engineers turned to quantization. We moved from 32-bit floating point down to 16-bit, and eventually 8-bit, just to keep the models running. But by 2025, even 8-bit wasn't enough. LLMs were demanding more context, and that's where the KV cache crisis began. The KV cache, or key value cache, is where a model stores every word you've typed so far in a session. It's what gives AI its memory. For a long context model like Gemini 1.5, this cache can consume hundreds of gigabytes of VRAM. This left no room for actual thinking. In late 2025, the industry was panicking. Inference costs were skyrocketing because we couldn't fit enough users on a single GPU. Then Google's research team published the polar quantization papers. They had found a way to go all the way down to 3 bits. 3-bit quantization sounds impossible. Usually cutting that much data makes the AI hallucinate or lose all its intelligence. But TurboQuant uses polar quantization. It maps data points to a spherical coordinate system, preserving the most important info while discarding the rest. Instead of a linear grid, TurboQuant sees data as vectors on a sphere. This allows for a much more precise representation of values even with only 3 bits per weight. The 2026 polar quantization benchmarks stunned everyone. It showed a 3.5x reduction in memory footprint with almost zero loss in logic. But software is only half the story. The real magic happened when this was applied to actual silicon, the TPUs and NVIDIA GPUs. Google's TPU v6 was the first to get native TurboQuant support. It was a match made in heaven for the Gemini family of models. On TPU v6, throughput jumped by 400%. This meant Google could serve 4 times as many users with the same hardware. But Google didn't keep this in a walled garden. They collaborated with NVIDIA to ensure TurboQuant worked on the H100 and H200 cards. The NVIDIA H200, with its massive HBM3E memory, saw even greater benefits. TurboQuant allowed it to handle context windows that were previously unthinkable. So who won? The TPUs had the edge in pure latency, but NVIDIA's ubiquity meant this would change the entire public cloud. For developers, the cost of running a high-end model dropped by nearly 60% overnight. This is the democratization of AI. There's an environmental win too. Less memory movement means less heat and lower power consumption across global data centers. If you're a developer, you might be wondering how to use this. The good news is that TurboQuant is already integrated into JAX and PyTorch. Open source models like Llama 3 are already seeing community-led TurboQuant implementations, making 70 billion parameter models runnable on consumer gear. This even trickles down to your phone. 3-bit quantization means powerful on-device AI that doesn't need the cloud at all. Imagine real-time, perfect translation happening entirely on your device with no lag. That is the power of memory efficiency. We're also seeing context windows move from 1 million to 10 million tokens, allowing you to process entire libraries of data at once. This solves the context forgetting issue. The AI can now remember everything you said 3 hours ago without slowing down. The industry headlines were unanimous. TurboQuant was called the most significant optimization since the transformer was invented. It forced competitors like AMD and Intel to rethink their memory architectures. Everyone is now racing to support 3-bit kernels. Cloud giants like AWS and Azure are already updating their hypervisors to handle TurboQuant kernels. No one wants to be left behind in the efficiency race. As we look toward 2027, the rumors are already swirling about 2-bit quantization. Could we go even further? The hardware roadmap for the next 2 years is entirely built around these quantization tricks. Efficiency is the new king. Eventually, AI will be like electricity, a commodity that's cheap and everywhere, thanks to breakthroughs like TurboQuant. In the near future, your personal devices won't just run AI, they'll run local versions of massive models, keeping your data private while giving you superhuman intelligence. For small business owners, this means you can afford to run sophisticated AI agents to handle your customer service and logistics. Even video generation is benefiting. TurboQuant allows for faster frame synthesis, bringing us closer to real-time AI movies. This is the true democratization of high-end AI. It's no longer just for the tech giants with billion-dollar clusters. To recap the technical wins, we solved the KV cache crisis, achieved 3-bit precision, and retained nearly all model accuracy. On the business side, we slashed costs by 60%, increased throughput by 400%, and made AI sustainable for the long term. The final verdict on the 2026 benchmarks? TPUs are the latency kings, but NVIDIA H200s are the value champions. Both are incredible. We are just at the beginning. TurboQuant is the foundation, but what comes next will be even more mind-blowing. I know some of you are worried about hallucinations with 3-bit models, but the data shows those fears are mostly a myth now. The lesson here is simple. Hardware and software must be designed together. That is how we truly unlock AI's potential. As we move forward, the barrier between high-end research and everyday application will continue to blur. TurboQuant is just the first step in a much larger journey toward universal AI accessibility. It's been an incredible journey exploring this revolution with you. Google TurboQuant is just one piece of the puzzle, but it's a piece that proves that with enough ingenuity, we can overcome any wall, physical or digital. Thanks for sticking around for this deep dive. Like and subscribe if you enjoyed it, and I'll see you in the next one.